Hello and welcome to this episode of the Azure Festive Calendar for 2021. My name is James Westall. I'll be your host this evening for my talk titled Azure AD Verifiable Credentials Buying into the Blockchain Hype Train. A little bit about me. My name is James, obviously. I work for a company called Arinco Australia. We help customers with M365 and Azure solutions. I'm passionate about security and identity as technologies. I'm a bit of a blockchain skeptic. Verifiable credentials, decentralized identities, what's getting me hooked on the blockchain. I write various blogs on security and identity topics at jameswestall.com. And if you'd like to work with me and you're in Australia, please don't hesitate, scan that QR code. A lot of work going on for us right now. We'd love to work with you. More important though, what are we going to talk about today? Right, so I'm going to start this session with some theory. We're not going to talk straight into the nuts and bolts of Azure AD. We're going to talk about what decentralized identity is, why you might use it, some of the key use cases. Then we'll touch on Azure AD Verifiable Credentials, what it is, how to set it up, etc. And we'll go through some demonstrations as well, issuing a verifiable credential, looking up information inside of the ledgers, and also the new request API, and we'll use Postman to access that without writing a lick of code. So, what is decentralized identity, right? As a technology, it's not Azure AD specific. So it's important to understand what it is, what the use cases are, why you might want to use it, even if you're not using Azure AD's solution. So importantly, decentralized identity is a mentality change as it relates to as identity solutions. For me, this is the most important thing. So traditionally, you would see identity, running out of a central provider. That might be your legacy Active Directory, it might be Azure AD, it might be Okta, ADFS, whatever. You've got a central service. If you're talking more broadly in the terms of identity documentation, it might be your driver's license issued from the DMV. It might be a passport issued by your government of the day. Importantly, all of those services, whether it's a technology service, a community service like a passport, are centralized. They rely on a party, and they are controlled by that external party more often than not. Decentralized identity is really about giving control back to the people who own the identities. So, for you and me, it's about us having control over our information, how it's used, and making sure that that's reliable and can't be taken away from us. You'll hear the term self-sovereign identity, talked about when you talk about decentralized identity, and they're one and the same. The QR code on the right there will give you a really great primer on what it is and why you should care about it. But for the purpose of this talk, it's really just you need to understand it's a mentality change. In terms of identity concepts, technologies, things you'll be used to already, decentralized identity is a evolution of existing concepts and technology that any IT pro generally should be used to already. So directories are still around, but they take a much more passive role. They're not as important anymore. Traditionally, where you would talk to a directory to verify data all the time, you're no longer doing that. Verifying parties are actually talking directly to the decentralized network and validating the ID data that way using blockchain. We still have things such as an issuer. So that example I gave of the government issuing a passport still exists, but they're issuing now what's known as a verifiable credential. And once you have that verifiable credential, you no longer need to talk to that issuer to actually prove that it is legitimate. It can't be taken away either. Verifiers still exist as well, right? And instead of consuming claims directly from an issuer, so for example, an OIDC token directly from Facebook, they consume the credential from the user, and rather than talk to the issuer, they validate that information using the decentralized network. So it's a lot less reliance on communication between the three traditional parties of an issuer, a verifier, and a user. At a high level, this is my favorite diagram that kind of really explains the way that decentralized identity works. So it's all built, for the most part, on top of the public blockchain, right? And what we're publishing into The blockchain is not the identity data itself, it's the verification data, that identifier that will actually allow you to verify a set of information. So we start on the left. We have an issuer, right? I'm going to use an example of a driver's license and the DMV. Now, the DMV in this scenario would issue you a driver's license. Now, what they do there is they say, okay, well, James is allowed to drive a truck. I'm allowed to drive a semi-trailer. Now, they will issue me a driver's license with, the details saying James can drive a B double, he can't, not wear his glasses, all that sort of information, my name, etc. And they'll give that to me. And what they'll also do is they will push critical information that, generally PKI style, public key cryptography style information to the decentralized network that can be used to verify the credential that they've given to me. Now, once I have that license, I can then sign it myself if I want and publish that signing information to the decentralized network, or I can, not sign it. Generally speaking, you'll sign it yourself as well. I have that, I own that, it's mine, it's on my device, it's wherever I choose to store it, and I no longer need the issuer, right? So they give me what they need to give me, in this case the driver's license, and then if I was to so choose, for the most part, I should be able to, wash my hands of them and say, now this is my information. Driver's license is probably, not. I need to keep that valid. I need to make sure I'm not speeding, etc. But the point stands. Once I have that information, in a verifiable credential, I can then present that to verifying parties. So, say for example, I go down to the pub. I'd love to buy a pint. I need to prove that I'm 18 in Australia, 21, in the States. I need to prove that I'm of age. I present that data to the verifier. In this case, the bartender looking at my driver's license. Now, for traditional identity, like if I had a physical driver's license, they're going to look at things like, does my license have a hologram? Does it have the appropriate QR code, or maybe like raised bumps or something like that that actually lets them validate that it's not some fake thing you printed off at eBay. For verifiable credentials and decentralized identity, what the verifier would do is they would look up the data on a blockchain service on the decentralized network without ever talking to the issuer. Right? Now, this is different to traditional identity. So, for example, OpenID, you might validate a credential by using an introspection endpoint. You might actually validate that a OpenID token is valid by looking at the signature data that comes from the issuer. You might be using introspection to do that. So you no longer have to, as the user or the verifier, the owner or the verifier, ever talk to that issuer again, which is really, really cool. Why might you use decentralized identity, right? I'm going to harp on 3 reasons here that I think are important. There's, for each person, these are going to be different, but for me, these are the 3 reasons that I think you should be using decentralized identity as going forward. The first one is reliability, right? We've all, a lot of people on this, watching this would have had experience with a data center, would have had experience, setting up public cloud as well. And that those services, when you build them, they're going to stay up according to their SLAs for the most part, but they can go down, and you are reliant on a provider in that scenario. When we talk about identity, having those services go down is, for the most part, not desirable, right? If you can't log in to another service, that's really frustrating. Verifiable credentials and decentralized identity in general are super reliable, right? And the reason for that is most of the time the credentials are stored locally. They're decoupled from any one point of failure, which is really cool. As long as you've got them with you, you can use them. And the way that works is obviously by not relying on a centralized service or centralized data centers, centralized network providers, by storing the verification information, the root of trust globally on the blockchain network, right? So because of the way that the blockchain works, being publicly hosted by multiple different people in multiple different locations, and also having consensus on, that is legitimate, you end up with a super reliable solution that avoids, common things like DC outages. Not a dig at any one provider, but they do happen, right? So in the last, 18 months, you've seen last week an AWS outage in US East 1. There was the October 4th Facebook outage, which was really impactful for some countries, especially those that relied on things like WhatsApp. You've got 2 Azure AD outages, and from memory, the second one was obviously caused by some fixes that were being implemented for the first one. And then you go back even further, you have another AWS outage, which you would think, looking at the screenshot there, is actually on Kinesis, not an identity service, but due to the way that a lot of public cloud works these days, is all the services are stitched together. The Kinesis outage actually caused an outage with Cognito, another identity provider goes down. So, verifiable credentials, they avoid some of those common, it's offline problems by being super reliable and not having a reliance on any one organization or party. The next reason I think verifiable credentials are really, really cool are trust and privacy, right? So decentralized identity, currently speaking, is cryptographically sound. It's built on modern protocols. It's quite new. It's very difficult to obtain fraudulent credentials, right? It's not impossible. So, for example, I could go after, someone could go after a issuer and then issue fraudulent verifiable credentials by compromising that service. That's entirely feasible, but that's a very high bar, right? Compare that to your traditional identity, things like a driver's license, right? For the most part, you could probably go online and Google where to get a free, a fake driver's license. The screenshot on the right took me about 25 minutes of Googling, if that, to get something for $70, which is really not great, because obviously the easier it is to get something fake, the less that people trust it. So being cryptographically sound, it's really easy to trust verifiable credentials on decentralized identity at the moment. The other bit that's really, really cool around decentralized identity is it enables privacy. Now, because it's built on cryptographic protocols and their data is signed, you can generally prove information without actually showing the source, right? So what I mean by that is, say for example, you wanted to buy a can of beer, right? And you go to the pub and you say, hey, I'd like to buy a beer, and the bartender looks at you and he says, well, you look a bit young, could you please show me your license or show me your proof of identity? And you provide a passport, a driver's license, proof of age card, whatever it is. Think about all the information you give over when you give that identity document to that bartender. You'd most definitely give them their age. That's the purpose. That's awesome. But you also probably give them things like, your first and last name, where you live, maybe where you were born. All this information, things that could potentially go into future phishing attacks, things that you might not want to let that person know. So, for example, driver's licenses will commonly have medical conditions on them. You might not want to give that information away. Decentralized identity is really, really cool because it's based on cryptographic protocols, is you can present an information in the form of a signature. So say, for example, you've had a proof of age card issued using decentralized identity. What you can actually do there is you can present the signature of that proof of age card with a detail about you, say, for example, your name, to that provider without actually providing your age, which is really cool. The way that would work is obviously your issuer would sign your verifiable credentials saying you are 22 years of age. You present that signature, and because it's cryptographically sound, that party who's giving you a can of beer can trust that you are of age regardless. This is actually a real world use case, right? So that picture on the right there of the vending machines was actually from a conference in Sweden where you could buy a can of beer without actually giving over that information to the company in question. The third reason that I think is really important, it's a little bit similar to the reliability one, is around longevity in communications. Blockchain, for lack of a better term, is forever, right? It's a ledger, it grows over time, it's got a consensus-based model. What this means is you can publish some information to it and have a high degree of confidence that it will still be available in a long period of time. obviously provided that that chain still stays in support. But for the most part, you can have a high degree of confidence if it's an established chain like Bitcoin or Ethereum or whatever. And that allows you to publish data for the longest term you possibly can, without actually having to host it yourself, which is really cool. Now, where that comes into really cool use cases is the longevity of information. So take for example the screenshot on my right hand side, right? So you've got a screenshot here of a news article. It's in Australia. It was a university that went bankrupt, and they had students who were attending there and doing their degrees. Think about those students once that university goes bankrupt, right? Things like a website, things like a building address, things like a admissions office, right? They're bankrupt. They all shut down. Now think about that student when they try and present their degree to a prospective employer. Prospective employer is doing their due diligence and would really love to validate that degree and say, hey, did they actually go to school? But they go look up the university and they can't find it, right? It's gone. Maybe they can find this news article saying they've gone bankrupt, but what if they don't? Right? All of a sudden, that prospective employer is looking at this poor student saying, hey, did you pull a dodgy and invent a university for me? Decentralized identity is really cool because it obviously enables that long-term beyond a operating identity scenario. You can verify information without ever interfacing or talking to the issuing party, right? Something that's a little bit different on the right hand side, but the bottom one, you've obviously got a vaccine certificate. It's quite old. It's from the Ottoman Empire. How would you go about verifying that today, aside from the historian says so? You probably wouldn't be able to, because obviously the Ottoman Empire is gone, and there's multiple examples of that sort of nation level entity even disappearing over history. So obviously, there's three core reasons why you'd want to use decentralized identity, but there's also other reasons. And really, I think the important ones, that when you compare decentralized identity to everything else, are the following core 7 tenets. So you've got autonomy, which means can you operate on your own? And you can see there that decentralized identity is the only one. You've got authority. Do you have full control? Decentralized identity wins out. Availability. Do you own your own data? Right? Are you the owner? At the end of the day, decentralized identity wins out again. Approval. Right? Things like, can you approve the usage of your data? Right? Your decentralized identity, including and also user-centric identity, are the only ones that win out. When you look at confidentiality, can you hide data? We talked about privacy earlier. Decentralized identity and user-centric. Decentralized identity is the only one that wins out there. Talk about tenacity, which is can you guarantee the data will remain available? Decentralized identity is the only one that can pretty much guarantee that. And then when we talk about interoperability, does this work for the most part globally? You can say yes, here it does work for the most part globally. My opinion really here is there's a bit to go, right? There's a little bit more development effort to go in this space, but it is one of a key driver. So you can see it wins out on the 4 categories, and I've just realized I haven't really explained the 4 categories. On the left, you've got centralized identity, which is your your Active Directory style scenario where your data is all stored in a directory. You've got federated identity, where your data is probably still in a directory, but it's being published out to other resource providers. That's your kind of ADFS, Azure AD scenarios. Your user-centric identity is similar to federated. You could probably lump the two in the same category, but this is more around things like Facebook and Gmail, where you've got a service that's just ubiquitous and is really focused on your user experience. But you can see across those 7 categories, decentralized identity pretty much wins out in all of them, or is comparable to the existing ecosystem. Let's talk about some use cases, right? It's important to understand why we would use it, but then maybe also where would we use it, right? The most obvious one, right, that you probably see today to a different, to varying degrees, is general identification, right? So in Australia, we have MyGovID, which is a digital identifier for, citizens of Australia. You've got, that would be a prime candidate for something like decentralized identity long term, right? Same for things like driver's licenses, passports, etc. Awesome, use case. gives full control to those to the people who have them, but also allows anyone to verify the information, which is really important. We also have an employee identification use case. So things like, do you work for my company? That's really easy to do with verifiable credentials. I personally see some of the really cool, I think the really cool use cases would be as a potential replacement for PIV cards, because it's obviously cryptographically sound. You can use it in those scenarios. Building access, same sort of thing. And then something that's really big in retail, and has been for the last 20 years, is loyalty and membership cards. So, have you spent, $1 million shopping at whatever, company it is? You have a loyalty card that proves that, and you can issue that by verifiable credentials or decentralized identity. The next use case is, and that I think is really awesome, is health, right? Obviously quite topical at the moment, being 2021, still dealing with COVID. Proof of vaccination, right? Everyone's, for the most part, getting vaccinated globally. So having that proof, that's really cool. Having that globally available on a decentralized ledger, that's even cooler, right? So proof of vaccination is a great use case. We talked about, decentralized identity enabling privacy. And I think in medical scenarios, this is like my favorite one, to be honest. When you consider the range of medical scenarios you have a lot of scenarios where someone might be entitled to something based on, how they are, right? So, there's people who have certain conditions or, challenges in their life that they can't avoid. They're medical, they're born with them, and they're entitled to benefits like that. Think of like, a disability parking spot as an example, right? You might want to be able to consume those services because you're entitled to them, right? But also, through years of experience, and it is really unfortunate and really horrible that this is the case, that sometimes people can be a bit nasty about it. You say, oh, you have that, challenge, right? That's really, not a great experience if you are dealing with those, dealing with those people. So I think decentralized identities, coolest use case here is obviously being able to prove that, yes, I'm entitled to this, right, because of X, Y, Z reason, without actually showing that source data, right? Same as I said before with the age, I'm old enough to buy alcohol. I'm entitled to this thing in my community, whether it be a disability, parking space, whether it be certain services at your local hospital, whatever it is, without actually showing that key data. And sometimes suffering from the unfortunate stigma that people apply there. Obviously, medical history as well, big use case, similar. You might want to present things like that you are free from certain diseases or something like that, without actually presenting what you've been tested for in the past, because people might make judgments there. So you can also provide that sort of information as well. The final use case that I think is going to pop up a lot is education, and I kind of touched on this earlier. Obviously, with an education provider going bankrupt, but you see that VC has a lot of use cases in student identification, proof of attendance, and graduation. Universities are really great at allowing access between them, from University A to University B, using it in those scenarios. Obviously, decentralized, easy for everyone to adopt. And also things like industry accreditation, like Susie is a verified accountant. James has an Azure Architect Expert certification. You could publish all that sort of information onto a decentralized identity solution. So I've talked about the technology as a whole broadly, but this is an Azure AD festive season, or an Azure festive season. So probably important to actually talk about Azure AD's service, Verifiable Credentials. To give you a quick summary of what it is, put simply, it's just the Microsoft implementation of decentralized identity. It's currently in public preview. It's quite new, I would say about 8 months old. And it's built on top of the ION network, which is actually on top of the Bitcoin mainnet. How it works, very, very similar to that earlier diagram. You have a decentralized ledger, in this case the ION network. which has information published to it, signing information on credentials. There's a verifiable credential request API, which is issuing a credential to a user that's stored in the Microsoft Authenticator application, and then that credential itself is presented out to services that verify who it is. So you send request and response to various services to log in, and they might use the resolver to verify that data on the DID network. What do you need to set it up these days? This may change. It's still in preview, so it comes with a caveat. You might need to revisit the docs as you go. But currently, you need a P2 licensed tenant. That's not a hard requirement long term, but it's an initial requirement during the public preview. You can get away without it, but you should have it, control of or access to a DNS zone. It's better with it, so I would recommend you have it. You need an Azure Key Vault, an Azure storage account, and most importantly at the moment, in my opinion, you need a little bit of tenacity. You need the patience to actually sit down and tinker with this. It's public preview. You do have to spend a bit of time reading and understanding the service to really get the most out of it. Enough about talking about it though. Let's give you a demo. Let's show you what it looks like. So what I'm going to do is I'm going to switch over here to my web browser. Now this is a tenant that I've spun up purely to do verifiable credentials. It has nothing else inside of it. I'm the only user within it. It's only got verifiable credentials in it, nothing else. And I'll show you how that's set up, etc. to get the end result on the left, which is actually my phone, showing two credentials. I've got a verifiable credential expert card, and I've also got an employee card from Arinco, my employer. So to get started inside of verifiable credentials, you actually need a couple of things in advance. Now the documentation covers this in much more detail than I can, but effectively what you need to get started is the following. When the portal loads on me. Yep. You need a key vault and a storage account. I have an ACR, a container registry, and a container instance as well in here. I'll touch on that in a bit, but I have these set up as well. But the minimum you need is a key vault and a storage account. Once you have those, you can go through enabling the service. So if I go to Azure AD, and then I navigate over to the security pane. So Azure AD security on the left, and then there'll be verifiable credentials about here from memory. My internet seems to be remarkably slow today, which is excellent. You can navigate from security to verifiable credentials preview. Now, if you haven't turned the service on for the first time, here you'll actually have a enable VC service option where you have to fill in some details. The details you need to provide here are the reference to the key vault that I just showed you, the domain you're going to use for your VC service, and also your organization name. I've already filled that out, so I don't have that prompt here. One thing to note is, I said earlier, obviously you need a P2 license. If you go through that initial setup when you do your tenant setup and you don't have a P2 license, you'll get a nice purple bar or red bar at the top saying, hey, you need a license to do this. I've set this up already, so I can't show you that. But if I go to organization settings here, you can see some of the information here. So my organization name that I provided is Arinco VC Demo. I've done this for my employer as well. You can see the key vault I'm specifying and the domain I'm using. Now, you'll notice here there's some other information. There's a decentralized identifier, which is really long and looks super gnarly. And there's also my tenant ID, which we don't care about. But on the left here, we've got a credentials button. And you can see when I load that up, I have two credentials set up, right? We'll go through what they look like and how to use them in the future. But that's effectively what you get once you set it up. Now, the experience with VC itself is pretty straightforward. So I'm using a corporate demo here that I built for my employer, and this is actually using a deprecated method. We'll touch on that in a bit. But we've got a setup here for verifiable credentials. I've got a website that sits at my domain, my VC domain. I've got an issuer website as well. and I've got a verify website that kind of is off to the side. So what I'm going to do is I'm going to go through the process of issuing a credential and then also verifying it, and I'll show you what that looks like. So if I navigate to this website, I've got some standard information, but I can click here and say get credential. And what you'll see there is I get presented with a QR code. I can mouse over the QR code generally and get a nice little actual link that QR code is going to, but I don't really care about that for here. And I'm going to scan that with my Authenticator application. Once I've scanned it, Authenticator on the left here is going to do a bit of thinking. It's going to come up and say, hey James, would you like to add a credential? Now, this is really important to note a couple of details. You'll see that I'm issuing a credential here from Decentralized Identity demo.arinco.com, organization name. I'm a verified organization, and I'm presented with what the card looks like and also some details about it. So in this scenario, it's saying sign into your account. So to get this VC, I have to have an account with this organization, which in this case is a demo tenant. I'm going to click sign in. Next to the magic of autofill, I'm going to have my password good to go, and then I'm going to click add. All right, verifiable credentials are added to my device. Now, you note obviously here I've got two verifiable credentials that say Arinco employee. That's because I've got two different tenants with the same information, but effectively I can differentiate those by scrolling through the application. So if I look here, I can actually click on that new credential that I was just issued. You can see it was issued on the 22nd of December. It expires next year in a month. You can see the details about me, the activity of it if I want to, when it was used, when it was used by, and also who it was issued by. So in this case, it was issued by did.demo.arinco.com. If I was to show you, for example, this other one, you can see that this is issued by vc.demo.arinco.com. So they're similar in appearance, but that's just my environment set up for demonstration purposes. Once I have a VC, I then want to use it, right? So this is up to the party that wants to accept VC on how they do so and what their purpose is. So you might just have it as your standard login portal, standard scenario to actually get into a website. I mentioned earlier, I think the building access use case, the PIV use case is really cool. So I can envision a scenario where maybe you sign up for like a corporate benefits program or something like that, and you want to access a building that's assigned to you via a corporate benefit, right? So this website here might display on something like a access panel at the start of the building. I can click verify access here and be presented again with another QR code, and I hope that this one scans because it was a bit flaky in earlier environments. I'm presented with another QR code and a prompt to say, hey, you want to log into the Super Snow Lodge, right? So my corporate benefit is entitling me access to a snow lodge because I love skiing. I've scanned the QR code and it's saying, hey, show me your employee card. I can click allow. It'll do some thinking, and then my website here will log in. It won't show me anything fancy. It'll just show me a welcome thing because it's obviously sitting on a front door somewhere. So you can say, now I've logged into to that location and potentially a door would open for me. Now I talked earlier before around what that activity might look like. So you can see here I've been issued this demo, and I've also had it presented that that information out to the verifier. So that's the high-level issuance and presentation flows for verifiable credentials. Now this demonstration, I was actually going to open source it, but it's actually using a deprecated version of Azure AD Verifiable Credentials, that being the SDK, which was the predecessor to the request API that I'll cover in a bit. But it does show the core capabilities of the platform, which is really important. There's a couple of things that I pointed out as we went through that flow. So if you were paying attention, you would have noticed that I had a verified tag on my credential when I requested it. When I actually got the credential, it said this is a verified provider of verifiable credentials. The way that that's done is via domain verification. So under organization settings here, you can see the domain I'm using, and that was verified by a well-known endpoint. So if I go and click verify this domain here, you will see a bit of information, similar, saying, all right, because I've got the right information hosted at the right location, I'm verified. And if I didn't have this, I hadn't gone through this process, I would be non-verified. Now, what it actually is to do that verification is the hosting of a JSON document at a well-known location, specifically this location here. So if I copy this location into this browser window, which is actually the same website, I get this JSON document, which is how I end up as a verified DID provider. And you look at this and you go, what is all of this gobbledygook, right? Importantly, that is a JWT, right? I called it out earlier, for identity folk, it's not that too much of a paradigm shift, but and you see that through the common reuse of technologies like JWTs. Once I've decoded that, you can see a bunch of information in here. You can see the KID is a DID identifier, the subject, the issuer, all that sort of information, right? Now you look at this and go, this is not super helpful to me, but I keep seeing this DID repeated. The subject, the issuer, it's the same thing repeated over and over again. I want to know more information about this, this decentralized identifier, what keys it has, where it's available. So I want to look that up in the existing blockchain network. To do that, these days you can actually use the IO End Explorer. So I've decoded my well-known document. I've grabbed the DID out of it, and I'm going to paste that into this search bar on the Identity Foundation Explorer. If I click search here, this is going to pull up more information about me. So obviously the way that this works is, this is the Explorer of the blockchain. Now, as I issue a key, or as I issue a verifiable credential, I'm signing it with information. And you can see down here some verification methods and some signature details. I sign that, and then I put that credential on the device. I can look up that DID, which is presented as part of the card and also via the well-known on the blockchain network, and get the counter signature information to actually say, oh, well, that was actually signed, and I can do the public key validation of those verifiable credentials and prove that they are accurate. So I've pulled out of the well-known, I've pulled out the DID, and then I can look that up in the ION network. So what we've covered so far: verifiable credential basic setup. It's a bit hard to show it once you've already done so. Basic flows, and also looking up the blockchain network. The next important thing is really important to understand is that verifiable credentials is still changing, and one of the biggest changes that's come about recently is the request API. So this demonstration I showed you here was using an SDK. That SDK is deprecated, right? It's no longer officially supported. It's still working, for the most part, but it's not the best practice process going forward. The way that the request API works is it offloads some of the core requirements, the core, the hard yards of actually issuing verifiable credentials to just a simple endpoint that you can call. So if I look up request API, there it is. Inside of the Azure AD document, I have an API for issuance, which is that first website I visited, and I also have an API for presentation, which is that second website I visited. So what I want to do is I want to give you a quick demonstration of how that works using Postman, and I'm going to show content that is also really well covered by a Microsoft video. So if you search requests API Azure AD Verifiable Credentials, there's this video from Mathis and Rohit is phenomenal, right? So I will put this link in the chat. But if you want to learn more about the API, I really recommend watching the Verifiable Credentials request video on YouTube. But yeah, well, I'll show you what that looks like now. So the request API obviously is designed to minimize the amount of time it takes you to get up and running with a verifiable credential. So what I've got here is I've got 4 requests. I've got 2 requests to issue a VC, to get one, and then also 2 requests to present VC, right? Request VC without a PIN, request VC with a PIN, request a single VC, and request a multiple VC. I'll show you what they all do, and then I'll show you like why you might use one versus the other. So this is a pretty stock standard Postman collection that Microsoft provides an example similar to on their Azure AD Verifiable Credentials samples. You know, I'm using just a basic requests. And what I've got here is I've got a standard authorization code flow set up. I believe with currently expired tokens. So I'm going to quickly get a new access token. Yep, use this token. Yep. And an API endpoint. Now, to that API endpoint, I'm sending a bunch of information. I'm sending a request to it saying I would like a QR code, which is what I was presented earlier in the website. I'd like that to be included in my response. I'm including a callback, which is a bunch of information where, which is an endpoint where Microsoft can actually send state details. I'm just using the example straight out of the documentation here. You can get away without this. And I'm also providing the information about what I'm requesting. So you can see here I'm requesting something from the DID authority, which is this DID here, right? And that's set via a Postman variable. You can see I'm providing some information about who I am and what I'm doing. So in this case, it'll be the client name issuer. And then I'm requesting some information about who I am. So I'm the verifiable credential type and the manifest. Now that's all provided via Postman environment variables. So you can see the DID authority here is this massive long DID detail. The manifest is actually a direct link to a credential that I've configured inside of the Azure AD portal. And then the VC type is actually just a summary name. So I have that credential already set up in this portal. When I call the request API for the first time, I get a response back that looks something like this. Now, if I said don't include the QR code, I wouldn't get this base64 encoded image, but I have requested it, so I get this data. Now, what was really beneficial for me from that request API video that I kind of mentioned earlier was the ability to visualize inside of Postman. I never knew you could do that before, so this is really cool for me. You can see here I've got the QR code. I haven't cut any code to do that. I've just called the API, which is cool. I can scan that on my phone, and you can't see that right now because it's on the other screen. I can scan that QR code on my phone and get a credential for, in this case, a festive Azure attendee. So I can come down and click add. Oops. No. I'm calling the wrong API. I can click add here, but it will fail. The reason it will fail here is because I'm actually calling the wrong endpoint. I'm calling it with the wrong details, which is a good segue. I'm going to request this quickly with I'm going to send this again, and I'll request it with the right information. Yep. Why is my access token no good? Yep, here we go. So I visualize, I'm going to get a barcode, I'm going to scan that, and then I can go back to my mobile app and show you the result there. I'm prompted for a PIN, in this case it's 1234. I'm going to click add, and I've added that. Now, that was actually a good, I suppose, demo fail. And the reason for that is it lets me show the two different types of the usage of request API. So if you were paying attention earlier in the demo, you would have noted that when I logged into the verifiable credential for the first time using the website, I was prompted for an OpenID Connect sign-in. I actually signed into my Azure AD tenant. Whereas when I requested this second VC using the API, I was only prompted for a PIN. And the reason for that is the request API in general is a lot more flexible in terms of actually issuing the VC. What I can do is I can provide the claims and the information I want to show in the VC in the initial request. And in those scenarios, I need to provide a PIN because I've got to do the verification of the, that I'm actually scanning the QR code and I'm authorized to do that. Or in other scenarios, I'm saying, I don't want you to issue a PIN because you're going to sign in when I issue the credentials. So it's really around, for me at least, when you authenticate the user. But the credential I've issued here is saying I'm providing claims in the credential as I issue it, and you can see that on my phone, obviously, as showing up as a festive Azure attendee. The way that works is you have a rules file and a display file. So if I open my display file here, I've got a Christmas attendee. I've got a JSON document that describes how that card looks on my phone, where it sits, what the details are, things like what to say when you're issuing it. And I also have a rules file that explains how that ends up. You'll notice here in the ID token, I've got a self-issued claim, which is provided through. I would use the self-issued claim when I just want to provide the rules in the request API. So I'm providing the claims through, I'm using this rule file that maps through to the claims here. For my corporate credential that I used earlier, you'll see here that I'm actually doing an OpenID Connect login and requesting standard OpenID scopes, OpenID and profile, which are then published back to the app. You'll notice I'm not using the self-ID claim because I'm logging in to get that. And when I call the request API, I'm doing that without the actual claims embedded because they are returned by my rules. The difference in the two files that I had was the first file, the one with the OpenID Connect, is this one. The second file, which I've included the claims in the request, is as the Azure attendee. So once I've requested a VC via an API, I might want to present it. Now the API is actually multi-service. You'll see that it all says request. The difference is what are you actually requesting? So in this scenario, you can see that I'm requesting presentation compared to the standard issuance. So I'm going to send this one through. Similar sort of setup. I'm requesting in this scenario an employee VC from the DID authority, which is the my decentralized identifier. I can click send. I need an access token. I can click that one, send. That should work now. Yep. I can click visualize, and again, if I go back, I've got a QR code, so I can scan that QR code on my phone. And if I go back to my mobile app, which is on the other screen, you can see that I have a request now for using my employee identifier, which is that Rinco employee one. I can also, using the request API, request multiple verifiable credentials. So in this scenario, I'm requesting the employee VC and also the Christmas attendee. But again, I can click send. I think I've authorized this one. Yep, cool. I can click visualize in this API. No, I haven't authorized again. Send. To uncreated, there we go. I can scan the QR code here and get a double request. So you can see here now I've got a request for my employee card and also my attendee card. And click allow and use both of those in the flow. No, I can't. Always the way with these demos. Works beforehand, doesn't work afterwards. That's fine. But you can see the point, right? You're being prompted for a second VC when you do that request via the API. So what I've showed you so far is the issuance flow when it's working using the SDK. I showed you the request API, which allows you to, using whatever you want, Node, .NET, etc., get like as in issue, and also request as in present verifiable credentials. I showed you how to look up data about them in the ION network, and I've showed you some of the basics of where the setup is. There's a lot in this solution as a whole. It took me forever to wrap my head around it as a whole. So hopefully I've provided enough of a primer for you as a user to actually get involved and use it yourself. But if you wanted to learn more, I would strongly recommend the following 3 QR codes. Right, so the one on the left is just the initial announcement that will help you to understand why you might care about verifiable credentials. The one in the center is on the Microsoft Docs, which is all of the information you need to actually get started yourself, including links out to GitHub samples and all sorts of amazing content that Microsoft has produced. And the one on the right is a bit more different to that. It's not Microsoft branded. It's actually the Decentralized Identity Foundation. And the DIF is a foundation that's actually specifying standards to be used by multiple providers, not just Microsoft, by other providers like Matter, who are able to use decentralized identity, and they're all contributing to these standards and really pushing the boundaries of what is possible with this technology. But with that, this is the end of my talk. Hopefully you've had some great value out of it, and I'd love to wish you a Merry Christmas and a Happy New Year. Until next year, team, have a lovely day.